Duolingo, the language learning app, had exploded in popularity with over 100 million monthly active users. However, their success came with a not-so-shocking surprise: potentially millions of dollars in annual AWS bills. In this video, let's learn how Duolingo reduced their AWS cloud bills by 20% through various methods. When Duolingo began their cost-cutting journey, they quickly realized they were flying blind. The first challenge was simply understanding where all their money was going. To solve this visibility crisis, Duolingo enlisted the help of CloudZero, a third-party service that transformed their billing data into queryable line items. This tool organized their cloud spending into a structured, searchable format that allowed engineers to drill down into specific cost categories of their AWS bill. They definitely found something alright. In one case, a staging environment was actually costing more than its production counterpart. Someone had scaled it up for testing but completely forgot to scale it back down. Imagine having to explain this to your boss.
Yeah, boss, I can explain. I was just practicing the company's value of thinking big, maybe a little bit too big.
With their new visibility tools in place, Duolingo's team began uncovering layers of waste throughout their infrastructure. First, they discovered that their S3 buckets were acting like a digital hoarder. AWS S3 is a scalable, durable, and secure storage object service that allows users to store and retrieve any amount of data from anywhere. Not only were they storing current files, they were also preserving the entire reversion history of these buckets indefinitely. Every file modification or overwrite was being kept, dating back to when the buckets were first created, far longer than needed for practical recovery purposes. I just hope that these buckets were not storing any of my bad pronunciations.
I see!
To fix this, they implemented lifecycle rules on their largest S3 buckets. They didn't really specify exactly what they did, but these rules can automatically manage the lifecycle of objects in a bucket by defining actions like transitioning objects to less expensive storage like S3 Standard IA or Glacier. I did some cost calculation in one of my previous videos if you're curious on this. Or automatically deleting older versions after they reach a certain age. By adding these rules, they can maintain reasonable historical access for recent changes while also preventing unbounded growth on their storage costs. The second example was their DynamoDB tables. DynamoDB is a fully managed NoSQL database service that provides fast, scalable, and serverless key value and document storage. They were accumulating large amounts of stale data that were no longer needed. DynamoDB charges based on both throughput and the total storage. They were effectively paying fees for all this data that had no more business value. The solution was to implement time to live, or TTL, rules on their DynamoDB tables. TTL is a feature that automatically removes item after a specified timestamp that exceeds a certain time. However, they encounter a significant challenge. You see, TTL rules only affect new data or existing data that hadn't yet reached their expiration. Their existing data didn't have this attribute from before, so adding it would require updating millions upon millions of records individually. So make sure you think about TTL when designing your database schema. It'll save you a lot of trouble in the future. The other issue that they faced was generating extremely verbose logs. When working with logs, the levels range from fatal, get out of your bed and fix this right now, to debug or diagnostic information. You can add as much or as little details to these logs. In Duolingo's case, every user action, API call, and system events were being logged at maximum details, including full stack traces for errors. Imagine if they were doing Java stack traces. These logs were being sent to CloudWatch, which charges based on both ingestion volume and storage duration. CloudWatch is AWS monitoring service that collects logs and metrics from your services to track performance and troubleshoot issues. To resolve this, they just stopped logging stack traces since they were huge. They also didn't really mention anything else, but some additional things that you can do is log only what you need to debug production issues, set appropriate log retention policy to automatically delete older logs, or possibly reduce the log level. Do you know any other tips? Please let us know in the comments below. They also noticed that most of their services were over-provisioned, memory allocations far exceeded actual needs, CPU resources were similarly wasteful. By right-sizing these resources and refining auto-scaling, they actually made massive savings. One over-provisioned service alone, once properly sized, saved them hundreds of thousands of dollars annually. Other issues include unused Elastic Cache clusters, databases, and even an entire microservice, many of which belong to legacy services that were fully deprecated. On top of wasteful resources, Duolingo realized that in their microservice architecture, a single user request can trigger a chain reaction effect where it could generate numerous internal API calls as services communicate with each other. To address these issues, Duolingo implemented two key strategies. The first is to visit each service and identify any unnecessary requests. They found a legacy service that triggered unintended side effects. For example, a simple data update might unknowingly trigger API calls to other services. In this instance, the single legacy service was causing 2.1 billion unnecessary API calls per day. They also found servers that were constantly requesting data from other services even though the request resource rarely changed. The service was using a cache but with an extremely short time to live of just 1 minute. By analyzing the data change pattern and extending the cache TTL from 1 minute to 1 hour, they actually ended up reducing the traffic to other servers by more than 60%. After digging through AWS documentations, they discovered built-in cost optimization features that they'd never activated. These specialized pricing options and configurations better match their specific usage patterns. A major win came with database optimization. They discovered cost savings policies for DynamoDB and RDS that specifically designed for certain read-write patterns. In their scenario, they saved several $100,000 annually just switching a single database to Aurora IO optimized configuration. Let's walk through an example just for storage. Let's suppose we have 1000 terabyte of data with 100 billion read and write requests per month. For standard pricing, it's 10 cents per gigabyte and 20 cents per 1 million IO operations, so the total would be around $30,000. As for Aurora IO optimized pricing, it's a flat rate of 0.225 gigabyte per month including IO operation, so it comes to around $22,500. So in situation where your workload involves both high read and write activity, Aurora IO optimized might be the better choice. Another AWS feature that they implemented is auto-scaling to reduce capacity during low traffic instead of running everything at full capacity 24/7. They also improved how they purchased and allocated reserve instances. By tracking their EC2, RDS, and Elastic Cache usage patterns, they identified their baseline compute needs. This data informed the bulk purchases of reserve capacity, ensuring significant discount compared to an on-demand pricing. The key lesson is that optimization isn't just about the resources that you provision, it's about how efficiently these resources communicate with each other. Reducing unnecessary traffic between resources can create a cascading cost savings across your entire infrastructure. They also didn't just stop there, they also expanded their monitoring to cover cloud services beyond AWS, including OpenAI. They integrated cloud spending data into their existing metric ecosystems and set up weekly reports so teams would passively monitor these services costs. Do you have any cool tips to help save money? I would love to hear about them. As always, thank you so much for watching and see you in the next one.